We begin our series of lectures on control systems. I must tell you that I expect you to be reading a book side by side with my lectures. As we go on, I will ask you to do some homework or do some home assignments. Of course, you will not be able to return them to me for my evaluation or comments, but it is important that you do the assignments that I will present to you. That way only you can learn as we go on. Now the subject is control systems. What are control systems? But before I give you the answer, let me tell you that in the room where you are seated right now, there are some situations which I call control situations. That is, there are situations where you would like to exercise control of some kind and you are able to exercise control of some kind. So can you look around you and find out what kind of control situations exist in the room where you are seated? I hope you have looked around. Look at the light in the room. There may be more than one. Now that's an example of what I call a control situation. Of course, as we all know, with every light there is a switch. And so this is the simplest type of control situation where you can either have something on or turn it off. These are indeed called on-off control systems. They can be as simple as a switch which turns a light on or turns a light off. There is no other option. You can either have the light on or you can have the light off. Of course, it does happen once in a while that you try to turn the light on, you turn the switch in the on position, but the light does not go on because of some problem with the light itself. Maybe the bulb has fused, or the starter is not working, or the choke is bad, or whatever. So in that case, there is no control action possible. You would like the light to be turned on, but it just cannot be turned on. But we normally expect that the light switch will work and you will be able to have the light either on or off. If the incident light that comes from the window is adequate, you may want the light off. But if it becomes cloudy, then the light is not enough. You will get up from your chair and turn the light on. Of course, one can have a much more sophisticated illumination system, as in a big lecture hall or a theater, where it's not just one light which is to be turned on or off, but a large number of lights, some of which may have to be turned on depending on the requirements. There is also provision for what is called dimming of light. The lights are gradually dimmed or gradually made bright. So this illumination control is a big area. But the simplest example of that is our ordinary light with a switch. Of course, when you have lights which can be dimmed, then the control is not simply on-off. And we'll see more of such things a little later. What else do you see in the room around you? Maybe above you or on the floor or on the wall, you see a fan. For example, there is the ceiling fan. Now that's also another control situation. If it's cool enough in the room, if there is fairly good breeze, then you may not want the fan on. But if it gets hot, you will get up and turn the fan on. But there is something more that is possible with the fan usually. There is also an arrangement for controlling the speed of the fan, which is called the regulator, the fan regulator. Because you may not want the fan to run at only one particular speed, you may want to adjust the speed depending on the conditions. Some people like to have the fan on at full speed. Others, like me, are uncomfortable if the fan is on at full speed. We like to run it at a low speed, just enough to produce some breeze and some ventilation or circulation of air. So in this case, the fan has a on-off switch, of course. You are able to turn it on or off. But in addition to on-off control, there is something more. Namely, the speed can be adjusted. Now, the old kinds of fan regulators had what are called notches. So you change the speed from 0 starting position to position 1, 2, 3, maybe full on. You make it cut, 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 cut. So that's how you change the speed. So the speed can only have a few levels as its values. The position is either 0, that is the fan is off, or 1, or 2, or 3, or 5, or 6, maybe it's full on, that is at the maximum speed. So here the choice is not between just on and off, but it's between one of a number of levels or values. Such a set of values is said to be a discrete set. So this is an example of what could be called a discrete valued control situation. Here you choose not between just on and off, but between more than two possibilities, namely 0 speed, full speed, or speed in between 0 and full. Of course, nowadays we have regulators, fan regulators, in which the speed can be varied almost continuously. So this kind of control action or control situation is called a continuous type of control action. You have a knob and you can turn it smoothly from one position to the other, going all the way from almost standstill to full speed. So besides the on-off control, which gives you only a choice between two values on and off, you may have a continuous type of control action in which on the face of it, you can vary the speed in any way you like, or it may be discrete, where you can select the speed or whatever other thing one is trying to vary between a small number of values. So on-off control, discrete valued control, and finally continuous control. Anything else in the room that you notice? We have looked at the illumination control, we have looked at the ceiling fan or the wall fan or the pedestal fan, and there what one controlled finally was the speed of the induction motor. Anything else that you see? Well, maybe you are seated in a room where there is an air conditioner, or very often it is just an air cooler. Air conditioner actually should condition the air, should control the humidity and the quality of air and so on. It should provide air coming from outside occasionally so that the air is refreshed. But usually what we have are only air coolers, although they are called air conditioners. Now here is another control situation. Of course, once again we have the on-off case. You may have the air conditioner switched off or you may have it on. But here you do something else. You set the temperature that you want. There is a knob or a control on the air conditioner panel, and you turn that knob so that it or adjust it. Nowadays there are cordless control units for air conditioners. You point your cordless unit after setting it and the temperature gets adjusted. Now here again you can set the temperature to any one of a range of values, maybe going from 25 or 27 degrees Celsius down to maybe 17 or whatever. It may be too uncomfortable, but still whatever suits you. So there may be what looks like continuous control action possible. You set it between a range of values, but there is a difference between this control situation and the earlier one where you turned the fan on or the light on or off or adjusted the speed. And what is the difference? The difference is as follows. In the case of the illumination control or the control of the fan, the control action was what can be called manual. In the sense, you had to get up, turn the light on or turn it off, or had to turn the fan on or adjust its speed. So this is called manual control action. And here is your first little exercise. I'd like you to look up a good dictionary and find out how the word manual, M-A-N-U-A-L, originated. What is the root of this word? As you know, many English words have arisen from either Latin or Greek or other European languages which are older or related to English, like German or Dutch or French and so on. So find out the origin of the word manual. So that's manual control. In the case of the air conditioner, of course, the control was partly manual because you had to set the temperature. You had to set the knob, or on the cordless unit, you had to set the temperature by pressing some switch or a button. But thereafter, you don't have to do anything. What happens is that as time passes, let's say it's getting hotter and hotter outside,